Alright, so in this video, we are going to be talking about slope and context. So our first problem is we're taking a class trip to Washington, D.C., and the graph below shows the distance we traveled. So we can see that we started out total time traveled. So at 0, we had gone 0 miles. And we went and traveled for an hour, and we had gone 60 miles. And then from hour 1 to hour 3, we had still only gone 60 miles. And then hour 3, we went up, and we can see these different segments. So our job is to find the average speed. So average speed is from the beginning to the end of that interval, about how fast were we going. So when I think about speed, I think about miles per hour. So that's a rate, that's a slope. So if you notice, miles is my y value, so really it's the change in y over hours is my x value, so change in x. So this is just slope, but in the context of a word problem. So my interval that I'm looking at is when x is between 3 and 6. So I'm going to start at 3, and I'm going to go to 6, and I'm going to see what's happening. So I can see that at 3 hours, I was at 60 miles. I had gone 60 miles. So I'm going to write the point 360. So 3 hours, 60 miles. And then at 6 hours, I had gone 270 miles. So I want to know what's the average speed. So how far did I go divided by how long did it take me, or change in y over change in x. So when I think about it, I like to do a table. So I have the point 360 and the point 270. So if I go from 60 to 270, I went 210 miles over the course of 3 hours. So change in y over change in x gives me 70 over 1, or 70 miles every 1 hour. So my average speed, I was going about 70 miles per hour. All right, Christina and Taeyeon say the average speed when 0 is less than or equal to x is less than or equal to 1. So basically between 0 hours and 1 hour is the same as when 8 is less than or equal to x is less than or equal to 11. So we're saying that the speed, or the slope, is the same. So let's go ahead and look and see what the slope is doing. All right, so from 0 to 1, we have gone, our average speed, we went from 0 to 60 in 1. So basically our table is 0 to 1 hour, we went 60 miles. So we went up 60 over the course of an hour. So my average speed in this interval is 60 miles per hour. All right, so from 8 to 11 is this interval. So I'm going to go up, and we're talking about from here to here. So I have to see what that pattern is doing. So at 8, it's at 360. So 8 hours is 360 miles I had gone. And then at 11 hours, I had gone 480 miles. So I'm going to find the change. So I went 120 miles over the course of 3 hours. So in this one, it's going to be 120 divided by 3, which gives me 40 miles per hour. So I can see that this line is a little bit steeper than this line right here. So they have to be the same steepness in order for them to be the same speed. So I disagree. And I'm going to say that from 0 to 1, they were going 60 miles per hour. And from 8 hours to 11 hours, they went 40 miles per hour. All right, Xavier is racing his little brother, and to make it fair, he's going to give him a head start. So the table shows how fast he runs. So this is Xavier, and this is his brother. So who runs at a faster rate, Xavier or his little brother? So what I have to do is I have to find out their different rates and then compare them. So go ahead and pause the video, and I'd like you to try to find the two different rates. All right, so hopefully you were able to find that Xavier's table is showing that he's going 4 meters every 3 seconds, whereas his brother is going 2 meters every 1 second. So there's a couple of ways you can think about this, because we can't compare those because we're talking about over the course of 1 second and over the course of 3 seconds. So one thing I could do is I could divide those, and I could say 4 divided by 3 and find out what that decimal is and compare that to 2. Or what I could say is if he's going 4 meters every 3 seconds, after 3 seconds, how far would Xavier's brother has gone? So if he's going 2 meters every 1 second, that's going to be 6 meters in 3 seconds. So I can use this idea of that rate, that constant rate of change, and I can look at how far he's gone over the same amount of time. So who's going faster? His brother's going 6 meters in 3 seconds, and he's going 4 meters in 3 seconds, so his brother is. And so how do I know is I'm going to use that exact thing, is that Xavier goes 4 meters in 3 seconds, but his brother goes 6 meters in 3 seconds. So he's covering more ground in the same amount of time. Alrighty, so we have a candle that's burning, and we can see its height over the course of time. So first of all, we have to prove that the rate of change is constant. So I need to make sure that it's increasing or decreasing by the same amount over the same amount of time. So here it's going down 1 over the course of 3 hours. So that slope is -1 over 3. And then it's going down 2 over the course of 6 hours. So that slope is -2 over 6, which reduces to -1 over 3, so we're good there. And then it's going down 5 over the course of 15 hours. So that slope is -5 over 15, which also reduces to -1 over 3. So I have proved that it's the same. So what does the rate of change represent in the context of this problem? Well, it's the change in y over the change in x. Well, y is height and x is hours. So what this means is the candle is burning at a rate of 1 inch per hour, 3 hours, because it's 1 over 3, so 1 inch per 3 hours. All right, so if I'm looking for how long, so I'm looking for the x value, because how long is measuring time, does it take for the candle to burn to the base? So I notice that it's going down at a rate of 1 inch per 3 hours. So I need to figure out if it's 4 inches tall at 24 hours. I just need to continue that pattern until I get to when the height is 0. So I'm just going to continue this table. And so I know I'm going down 1 every 3 hours. So I'm just going to rewrite my table here of it's 24 hours, it's 4 inches tall. So I'm going to go down an inch every 3 hours. So when I get to 27 hours, it will be 3 inches. I'm going to go down an inch every 3 hours. So another 3 hours have passed and it's gone down. I'm going to go down an inch, another 3 hours, and I will finally get to, at 36 hours, it will have burned to the base. right, so for question 3, I want to, this was a typo. I need you to change seconds to minutes. All right, so how tall is the candle? So we're looking for Y after it burns for 180 minutes. Well, I noticed that my time is in hours, so I need to think about 180 minutes is how many hours? Well, that's going to be 3 hours. So when 3 hours have passed, how tall is it? It's going to be 11 inches tall.